Even though an example is given for hydrogen on how to find the average atomic mass, I thought it'd be helpful to go through one example. So I'll do the potassium. If we're going to complete this table first, that will be helpful. So K39 means atomic mass of 39. All potassium atoms have 19 protons, so that should be relatively easy. And then we're going to assume a neutral atom, so it'll have 19 electrons. So what's different about each isotope is the number of neutrons. If it's K39, potassium 39 is going to have 20 neutrons. K40 is going to have 21, so our symbol needs to reflect that. 19 and 40. If it's got 19 protons, it has to be potassium. And this last one is K41. So to find the average atomic mass, we're going to have to calculate it. You could look on the periodic table, but I'm asking you guys to find it based on these numbers. So in order to find average atomic mass, you can't just do an average and add the three masses and divide by 3 because there are not equal amounts of each of those. So what we have to do is a weighted average and say the percentage turned into a decimal, which is 0.9326. It's another way of saying 93.26% is the main potassium isotope, and then multiply that by its atomic mass, which is not exactly 39, it's 38.96. If we do that for each of the three potassiums, be careful with your decimal places. It's 0.001. That's how you say 0.1% of potassium 40. And then that is 39.96. And if I add one more isotope in its abundance, 0.0673 times 40.96. I'm going to pause for 1 second to type this in my calculator. After typing in the calculator, I get 39.0947. For 7 AMU. We're going to round that because all of these were given as 4 sig figs. So 39.10 AMU. If I look on the periodic table, that is very, very close to the 39.098 shown, or 39.10 on some periodic tables. So it's really nice to see if your calculated value matches up with the average value that's on the periodic table. That's if you know the element. 3, 4, and 5 are similar, although 5, the order is different, so I'm going to leave that as a little bit of a challenge for you. Good luck.